Hello everyone, welcome to part 6, or you can call it as lecture number 6 of the CSAT 2024 series. In this particular video, as you can see, we will be talking about the combinations part. We have already started with permutation and we have covered 2 lectures on permutation. So if you have not seen those videos, I'd request go back to the playlist and check those videos and come back for a better understanding of permutations and combination. In this particular video, we'll solely talk about combinations. Alright, you know the drill. We have got few PYQ questions that have been previously asked, and we'll start with this once we are done with the concept for combinations. Alright, first things first. What is the basic difference between permutations and combination? And I feel all of you know this by now, that permutations are arrangements of elements in which the order of elements does not matter or matters. Order of elements matter. In which the order of elements matter. Combination, on the other hand, talks about selection of elements in which the order of elements does not matter. So this is the most basic point of difference between permutations and combination. In the previous video, we have dealt on these 2 points in depth. So you can always check that. Now, what are the formulas? The formula for permutation is simple, NPR. And how do we break NPR? N factorial upon n minus r whole factorial. And when we talk about combination, it is NCR. And when we break NCR, it is something, right? N factorial upon n minus r whole factorial into r factorial. So in other words, we can say NCR is nothing but NPR upon r factorial. So you can also write it as, this is NPR upon the r factorial. Alright. How many ways can you select all in all? All in all selection. That is NCN selection. That is in one way. Also, how many ways can you not select a particular point or a particular person? How many ways can you not do a particular task? That is one way. NC0 is also one. So these 2 things should be very clear to everyone. That is, number of ways of selecting all in all. That is one way. Number of ways of not selecting a particular person. That is also one way. Alright, let's move forward. There are certain shortcuts using which we deal with this formulas of permutation and combination. What are they? When we talk about 4p1, we are actually talking about this as, how do we break 4p1? 4 factorial upon 4 minus 1 factorial. This is 4 factorial upon 3 factorial. Or this is 4 into 3 factorial upon 3 factorial. And ultimately we can say the answer boils down to 4. So 4p1 is actually 4. And when we talk about 4p1, we also have a shortcut of looking at it, which is something like, you go back one place. So one place means we go back only one time. That is 4. 4p2 means go back 2 places. So 4 into 3. That is the value for 4p2. No need to do it with the help of formula. Therefore, we have a shortcut. Now 4p3 would be simply 4 into 3 into 2, 3 places. 4p4 is simply 4 into 3 into 2 into 1, 4 places. And you know for a fact NCN is 4 factorial as well. Now, talking about the shortcuts for combination, combination is nothing but NCR is nothing but NPR upon R factorial. So how do we break 4P1? We write it as one step. So we write it as 4, whatever it is. So how would we be writing 4C1? We would be writing it as 4 upon R factorial. R here is 1. So 1 factorial. Now how do we write 4C2? 4C2 would be something like 4 into 3 upon 2 factorial. How do we write 4C3? 4 into 3 into 2 upon 3 factorial. How do we write 4C4? It is nothing but 4 into 3 into 2 into 1, 4 places, then R factorial. I hope you have a better understanding now. How do we deal with these evaluation when we talk about their shortcuts? We can always use the formula, but I'm saying there are certain shortcuts that we should know. Alright, let's talk about a question. Very simple question. In how many different ways can 3 persons be selected out of 5 persons? Now, how many persons are there? 5. So n value is 5. How many you need to pick or select? 3. So R value is 3. NCR, which is 5C3. How do we break 5C3? 5 into 4 into 3 upon 3 factorial. This is 5 into 4 into 3. 3 factorial is 3 into 2, which is 6. Let's simplify. So this is 10 ways. Done. Next. How many different ways can 5 persons be selected out of a total of 5 persons? N value is 5, R value is 5, therefore NCR becomes NCN, and we know NCN is one way. We can always check this as 5C5. It is 5 into 4 into 3 into 2 into 1 upon 5 factorial. One way. I hope all of us are following this and we are on the same page. Okay, let's move forward with few more questions on combination, and as we keep on doing questions, our concept would become easier to understand. Chalo, let's move forward. A team of 3 persons has to be formed having at least one man. Out of, there are a total of 4 men and 3 women from whom we can pick. So this is my option set. How many different ways can the team be formed? Our ultimate aim here is to form team. And when we talk about a team, every team must necessarily comprise of 3 members. Okay. Also, each team must have at least one man. If we are forming a team which has no man, that will not be counted as a required selection. Okay, so can we say, let's say case number 1, we have only one man and 2 women. Now please tell me, how can we pick one man out of 4 men? 4C1 ways. Having done this, I have filled only one spot. I have only selected one person. So I have selected one member of the 3-member team. Now I need to select 2 more members, and these members are necessarily the women. How many women do I have in total? 3. How many do I need to select in order to make our team? 2. So this is 3C2. What do we have here? We have 4C1 as 4 and 3C2 as 3 into 2 by 2, which is 3. So in 12 ways. Okay. Now can we have a different case? Let's see. Case number 2. Now, in this case, can we say we can have 2 men and a single woman? The team must comprise of at least 1 man. So yeah, we have 1 man at least. Okay. How can we select 2 men out of 4 men? 4C2 selections. How can we select 1 woman out of 3 women? 3C1. Let's break. 4C2 can be written as 4 into 3 by 2 factorial. This is 6. And 3C1 is written as 3 by 1 factorial, which is 3. This is 18 ways. Next, if we have a next case, let's see. Can we say the team that we're looking out for may comprise of all men? All men means at least 1 man is necessarily there. Now, how can we select 3 men from 4 men? 4C3. How can we not select a woman? See, there is no woman, right? There is no woman. How can we do that? 3C0. Okay. So what is 4C3? 4C3 is simply 4 into 3 into 2 upon 3 factorial, and 3C0 is 1. So we have 4 ways. Now, can we have any other case? Just look at it and tell me, can we have any other case? I don't think so. So ultimate answer is always the summation of all 3 cases. So case 1 plus case 2 plus case 3. So we have 12 plus 18 plus 4, which is 34 ways. So in 34 ways, we can form a team which will always comprise of 3 members, and the necessary condition, that is, each team will necessarily have at least 1 man. So the condition is also filled, and we see we are getting total of 34 such selections. Now, this is one way of looking at it. That is, this is one solution. Can we solve this question with any other method? Can you think of a different method to solve this particular problem? Let's see. I hope the first one is clear. Let's talk about a different method altogether. Now, without any necessary condition, that is having at least 1 man, how can we select 3 members out of 4 plus 3 members? That is, irrespective of the constraints of the question, if we are randomly forming a team in which we need 3 members, so how can we do that with the help of 4 men and 3 women? So my n value becomes 4 plus 3, and my r value is 3 because we are looking out for 3 men or 3 persons to form the team. So this is total selections, which is 4 plus 3 is 7. 7C3. How do we break 7C3? 7 into 6 into 5 upon 3 factorial. Now 3 factorial is 6, so 6 and d is gone. We have total selections as 35 selections, or in 35 total ways we can form a team of 3 members. We can form a team of 3 members. Now, what do we need? In the question it says at least 1 man must be there. So at least 1 man can be equal to total selections minus no men. And no men means all women. Just think about it. Our question here says we are looking out for the number of selection in which there is at least one man. At least one man. So what I do? I take out the total selection irrespective of any constraints. From that, I take out all those selections which contain no men. And no men means all women. Okay. So let's talk about all women. Women. Okay. The team comprises of 3 women. And how can we form 3 women team? From the 3 set of women that we have. So C3, that is 1 selection. Now, total selection is 35. No men selection is 1, as we have seen. So at least 1 man would be 34 selections. At least 1 man. I hope you are following this. A shortcut. In part 1, we have done so many questions like this, wherein vowels are always together. So you take the total permutation minus vowels are never together. That is what we are doing here. At least 1 man must be there. So we take the total minus no man. So whatever selection that we look out for is containing necessarily 1 man at least. So 34 is what we have, and we have done this with the help of 2 methods. This is method number 2 of solving such type of questions. Alright, let's move forward. Another very important question based on combination. Very important, very interesting question. Let's first understand this with the help of a very smaller value. Here the question is for 11 members. Let me just do it for 4 members. Let's say we have A, B, C and D. 4 members. Now the question says, every student shook hands with every other student. Everyone is shaking hands with every other person. How many handshakes took place? Let's start by doing it manually. Because we have a very lesser number, we can do this manually. Just to understand the concept here. A would be shaking hands with B. A would be shaking hands with C. And A would be shaking hands with D. So for A, we have got 3 handshakes. Now, very interesting part. When we start with B, we will not consider B shaking hands with A again. Because just think about this. You are shaking hands with a particular person. That will amount to 1 handshake. The other person will not necessarily handshake with you another time. No, it's not necessary. Right? So B would be shaking hands with C. And B would be shaking hands with D. So for B, we have 2 more. Now, when we talk about C, C has already shaken hands with A and already shaken hands with B. So C would be shaking hands with D only. So 1 more. Now when we come down to D, we have an observation which says D has already shaken hands with the 3 persons. You can see clearly. D has shaken hands with A, D has shaken hands with B, and D has shaken hands with C. So every person has shaken hands with every other person. Now, for 4 members, when the number of members is 4, the answer is 6 handshake. Right? This with the help of manually solving it. But can we have a formula here to find the number of handshake? Yes. We have a formula which is known as NC2. And why do we write it as NC2? Because for every handshake to take place, you require 2 members at the same time. So let's do it for 4 members. 4C2, 4C2 is 4 into 3 by 2 factorial. 6 handshakes. 6 handshake is what we have. Now, for this question which has 11 members, 11C2 is our answer. 11C2 can be written as 11 into 10 upon 2 factorial. So this is total of 55 handshakes. So if we have a class of 11 students and every student is shaking hands with every other person, then in that case we have got 55 handshakes. Now a very important point that I'm going to discuss, so please be very attentive. When A to B is same as B to A, which means if A is shaking hands with B, then we call it a handshake, which means B is also shaking hands with A. Example, handshake. We use combination here. And the formula is NC2. Alright. Another important point. When A to B is not considered as B to A. Suppose you are giving out an article to the other person. You are giving a chocolate to B. Will it be considered that B has also given you a chocolate? No, until unless B gives you a chocolate. So A to B is not equal to B to A means we are talking about article distribution. You can say you're distributing chocolate, you're distributing cards, wedding cards, invitation card, or you are slapping the other person. All of these cases we use permutation. And what is the formula? NP2. When this is equal, we use combination. When it is not equal, this means it is not equal, we use permutation. I hope you are following this, all of you. Now let's be done with few questions quickly. In a class of 11 students, every student shook hands with every other person. Find the total number of handshakes that took place if it is compulsory. What is the total number of handshake? NC2. So this is 11C2. But we have also a constraint that says it is compulsory to shake hands once in the morning and secondly in the afternoon. So it is 11C2 into 2 because total number of handshake is 2 times. So this is 11 into 10 by 2 factorial into 2. (55 into 2 is 110 handshakes. Done. Let's move forward. Okay, what could be the other cases in which we can use this combination formula? First is in cases of handshake. Second is in questions of hugs. When you give a hug to the other person. Or when you are playing match against each other. Let's say India is playing against Australia. This is considered as one match. So we'll not count it as Australia versus India another match. A to B is equal to B to A, we'll use combination. I hope this is clear. When we are looking out to do comparisons between certain persons in order to rank them among themselves, again we'll use combination. Let's see. Each person's performance compared with every other person is to be done in order to rank them, the group that we're talking about, them subjectively. How many comparisons are needed if there are a total of 9 persons? So A, B, C, D, E, F, G, H, I, 9 persons. A will be compared with B, C, D, E, F, G, H, I. And similarly, since B is already compared with A, B would be compared with C, B would be compared with D, E, F, G, H, I. C will only be compared with D, E, F, something like that because it has already been covered in the previous cases. Now, we simply use the formula for combination and that says NC2 and we have 9C2 as 9 into 8 upon 2 factorial. 36 comparisons. I hope this is clear. Now, let's do one more. In a tournament, there are 14 teams that play league matches. How many matches are to be played if each team plays against every other team only once? Number of matches is NC2, 14C2, 14 into 13 upon 2 factorial. 13 into 7 is 91 matches. Typical question on combination. So, a very important question here. Avishek has got 5 friends. In how many different ways can he invite any number of friends to a party? At least one friend to a party, at least 2 friends to a party, exactly 2 friends to a party. How many friends do I have? 5 friends. I'm a lonely person. I've got 5 friends. Exactly 2 friends. Out of 5 friends that I have, I'm inviting exactly 2. 5C2. And how do we break 5C2? 5 into 4 by 2 factorial. 10 ways. 10 ways for this question, that is 4th number. Now, let's talk about at least one. So it is up to me or it is up to Avishek to invite friends. Avishek can choose to invite only one friend, 5C1. That is case number 1. Can be a possible scenario. I have got 5 friends, but I choose to invite only one. Now, another scenario says, I could have chosen to invite 2 friends. That is also possible. So, another case, and since cases are always added up, you have seen in every question, the ultimate answer is the summation of the cases. Cases are always added up. Therefore, we write it as case number 2 plus 5C2. Or Avishek can choose to invite 3 friends at the same time. Or Avishek can choose to invite 4 friends out of his 5 friends. Or Avishek can choose to invite all 5 of his friends. Now let me quickly break this down. What is 5C1? 5. 5C2, just now we have solved 10. 5C3, 5 into 4 into 3 by 3 factorial, that is also 10. 5C4 is 5 and 5C5, that is 1. So the correct answer here is 31 ways. Now, please pay attention. Next question says, at least 2 friends. So can we start from here? At least 2 friends. 5C2, 5C3, 5C4 and 5C5. 5C2 is 10, 5C3 is 10, 5C4 is 5 and 5C5 is 1. So this is a total of 26 ways. Done. Now, let's understand one more thing, that is any number. Any number means now Avishek has the option, with any number Avishek has the option of not inviting anyone. That is 5C0. Avishek can choose not to invite a particular person. Then we can have all the other cases as we have. So he can choose to invite one person, he can choose to invite two persons, or he can choose to invite three persons, or he can choose to invite four persons, or he can choose to invite five persons. 5C0 or NC0, all of us know it is 1. So up from 5C1 to 5C5, the answer is 31. That means from here to here, the answer is 31. NC0 is 1. So this answer is 32. Now, let's talk about at most two friends. The maximum that we have is 2. So the minimum that we have is 0. So for the fifth question, we can start by not inviting someone, or inviting just one person, or the maximum limit, that is 2. At most 2 means maximum 2. At least 2 means minimum 2. That is the difference. At least 2 means minimum 2, at most 2 means maximum 2. Alright, let's break this down. 5C0 is 1, 5C1 is 5, 5C2 is 10. So this is 16 different ways. So in 16 different ways, this can be done. I hope this is clear and you are following this. But we also have a shortcut formula to deal with these type of questions. Please note down this formula, it's very important. NC0 plus NC1 plus NC2 plus NC3, and this goes up to NCN. If we are adding all of this, then the solution is simply 2 to the power n. Very important formula for combination. NC0, NC1, NC2, NC3 going up to NCN. The summation is equivalent to 2 to the power n. Let's see. NC0, 5C0. So this is simply, as I said, 2 to the power n, or 2 to the power 5, which is also 32. I hope all of us are on the same path. Now, having understood this, let's do few questions quickly. And let's be done with the PYQs quickly. Okay, this has been asked in the previous year, 2023. There are 4 letters and there are 4 envelopes. And exactly one letter is to be put in exactly one envelope with the correct address. So for our better understanding, let's assume the 4 envelopes are envelope number 1, envelope number 2, envelope number 3 and envelope number 4. Since all of these 4 are unique, which means all of them, each letter will go into any one and exactly one envelope. Let's say letter 1 must be going into letter 2. Envelope number 1. Letter 2 must be going in envelope number 2. Letter 3 must be put in envelope number 3 and letter 4 must be put in envelope number 4 with the correct address. So these are the correct order. Let's just assume. Now, if the letters are randomly inserted into the envelopes, then consider the following statements. Let's talk about statement number 1. And let's please understand statement number 1. Let's try and understand statement number 1. It says, it is possible that exactly one letter goes into an incorrect envelope. Okay. Let's assume letter 1 goes into an incorrect envelope. So letter 1 must be going in envelope number 1, but since it is going incorrectly, so it can go into either E2, E3 or E4. For our better understanding, let's assume letter 1 goes into E2. letter 1 goes into E2. Now, if this is happening, then in that case, letter 2 which was supposed to go into E2 cannot go into E2. So letter 2 will also go into either E1, E3 or E4, and thereby it will disrupt two letters. That means it says exactly one letter goes into the incorrect envelope. This is impossible. If one is falsely placed or incorrectly placed, naturally the other one will also be incorrectly placed. So we cannot have one case exactly. We can have at least two cases. At least two letters will go in wrong envelopes. At least two. The minimum is 2 and not 1. So this first statement is absolutely false. It is impossible. It cannot happen. So this is crossed. 1 does not follow. Both 1 and 2 does not follow. 1 is absolutely wrong. Okay, now let's see. There are only 6 ways in which only 2 letters can go into the correct envelopes. Now, the order does not matter. Since the order does not matter, we are looking at combination. So let's see how many combinations can we have. For our better understanding, let's start with, we know the formula, right? Only 2 letter goes into the correct envelope. How many letters do we have? 4. Only 2 is going correctly, so 4C2. 4 into 3 upon 2 factorial. The answer is 6 ways. Let's see. There are only 6 ways. Yes, this is absolutely correct. Now, if you want to again further understand this, so let me just break this down. What could be, since these are just 6, very simple, very lesser in number, so we can also write down these 6 arrangements as well. Let's see. Letter 1 and letter 2 are correctly placed, and letter 3 and letter 4 are wrongly placed. Or letter 1 and letter 3 is correctly placed. Or letter 1 and letter 4 is correctly placed. Now we have exhausted all the possibilities with letter number 1. Let's start with letter number 2. Letter number 2 and letter number 1 we have already taken as a combination. So we have to take letter 2 and letter 3 as one of the combinations, and letter 2 and letter 4 as one of the other combinations. Next, we can also take letter number 3 and letter number 4, because we have already taken letter number 3 and 2, letter number 3 and 1. So as you can see, 1, 2, 3, 4, 5, 6. 6 ways only 2 letters can go into the correct envelopes. With the help of formula, with the help of logical understanding, we have done this question. Chalo, let's move forward. A selection is to be made for 1 post of principal and 2 posts of vice principal. This has been asked in 2015. Among the 6 candidates called for the interview, only 2 are eligible for the post of principal. How many principal do you want to select? 1 from 2. So principal and vice principal VP. Out of 2, we are selecting only 1. 2C1 ways. Into. How many members do we had? 6 members. Out of this 6 members, 1 will be selected as the principal. How many are we left with? Now, since 1 is already fixed for the principal, and it says they are all eligible for the post of vice principal, but 1 person is not eligible because 1 person we have used as the principal. So that will not be counted here. So how many are we left with? We are left with 5 members. And how many we can select? 2. There are 2 posts. So we will be doing it as 5C2. Now, 2C1 is 2, 5C2 is 5 into 4 by 2 factorial. So this can be done in 20 possible combination. Option D is the correct fit here. 20 combinations, option D is the correct fit. Let's move forward. How many different sums can be found with the denominations rupees 50, 100, 200, 500 and 2000? All of them are different from one another. So we have got how many types of denominations? 5 types. Okay. Now, out of these 5 types, we can have to take at least 3 denominations at a time. At least 3 means out of 5, n value is 5. We can start by taking 3. So, first case 5C3. Second case 5C4. And the last case is out of the 5 denominations that we have, we can pick all 5. 5C5. What is 5C3? 5 into 4 into 3 upon 3 factorial plus 5C4. 5 into 4 into 3 into 2 upon 4 factorial. 5C5 upon 5 factorial. Let's break this down. This is simplified as 1. 4 factorial, 4, 3, 2. This is simplified as 5. 3 factorial means 6. So 3 2s are 6. 5 2s are 10. 10 plus 5 plus 1, that is 16. So in how many different ways? In 16 different ways can we select at least 3 out of the 5 denominations that we have. Option A is the correct fit. This has been asked in the year 2020. The examinations were held somewhere around October for the year 2020. Alright. Next. In a tournament of chess, 150 entrants, a player is eliminated whenever he loses a match. It is given that no match results in a tie or a draw. How many matches are played in the entire tournament? For these type of questions, please understand the number of matches is always equal to n minus 1. So that is 150 minus 1, which is 149 matches. Simple. Now, if you want to understand this, please be very careful. At a time of playing chess, you need one team, one player. Okay. So out of 150 players, we can have how many matches at first? 75 matches. 75 matches. Next, divide this by 2. Divide this by 2, you'd be getting how many? 37 matches plus 1 carry forward. 37 into 2 is 74 plus 1. Now we have 38 because the winners will go forward. Why? Since we said 150 entrants are there and we said 75 matches. So in the next case, 75 players will go forward. 37 matches plus 1, so 38. Here 75 went to the other round. Here 38 went ahead. And from this we can say 19 matches were conducted again. Matches. Okay. Now 19. So we conducted 9 matches plus 1 extra. So now 10 players were carried forward. 10 players, we have got 5 matches. So 5 players went to the next round. Now, out of these 5, again we can have 2 matches. 1 is carried. So we have got 3 members now, 3 players. From 3 players, again 1 match is being played and 1 is carried. So now we have 2 players, 1 more final match. Now, if we add all of this matches, only the matches, we'll get this as 149. So you can always start this by taking n minus 1 as our formula, and you will never make a mistake when you are doing this. So with this, I feel your combination part is also clear. See you all in the next video. Till then, keep learning and happy learning. Also, please check the logical reasoning playlist. Logical reasoning playlist. And with that, try to cover blood relation, coding, decoding, calendar, syllogism, direction sense, all of these topics. It's very important. Chances are cubes and cuboids as well. High chances of getting reasoning question for the year 2024 CSAT. So please prepare these topics as well. Chalo, take care. Bye bye. See you all in the next video. Happy learning.